Okay, lesson 10. How do I solve proportion problems using ratio tables and factor puzzles? So this should sound a little familiar to you. We're going to be looking at ratio tables, we're going to be looking at factor puzzles, but we're going to be using them to solve proportion problems. So we're going to talk about what a proportion is. So first, a proportion is when you have two equivalent ratios. So remember back to the pencils and erasers example. I brought in 4 pencils and 7 erasers every day. By the second day, I brought in 8 pencils and 14 erasers. These are actually examples of equivalent ratios, but it also is an example of a proportion because 4 to 7 is equivalent to 8 to 14. Two ratios that are equal to each other make a proportion. Any two rows from a ratio table are going to make a proportion, right? Any two rows that are equal to each other, there's your proportion. Now, in a proportion problem, one of the 4 numbers is going to be missing. So maybe I don't have this 14 anymore. Maybe I'll put, I don't know, a letter in its place, like E for erasers. I am missing the number of erasers. I have one number of the 4 that's missing. That is going to be solving a proportion problem. And I know that you have done other problems just like that, where you were given 3 numbers and you had to figure out the 4th one. Sounds like a factor puzzle, right? Take a look at this proportion problem. Grandma made applesauce using the same number of bags of red apples and bags of yellow apples. Her red apples cost $6 and her yellow apples cost $14. I used her recipe but made more applesauce. So it's the same recipe, the same ratio of red to yellow, but obviously we made more of it. I paid $35 for my yellow apples. How much did my red apples cost? So this is what the proportion looks like. This is the original ratio that was given to us, 6 to 14, right? $6 for red apples, $14 for yellow apples. And now we have to figure out how much are the red apples going to cost if we're spending $35 on yellow apples. So we're going to solve this proportion. We're going to figure out that missing number. One way to do this is by using a ratio table. Now remember, with a ratio table, we need to have the basic ratio at the very top. The basic ratio is the ratio that is in simplest form. So if I have 6 to 14, if I simplify 6 to 14, that's going to give me 3 to 7. That tells me that the basic ratio here is going to be $3 for one bag of red apples and $7 for one bag of yellow apples. So, one bag is $3 for the red, one bag is $7 for the yellow. Well, what if I'm talking about 2 bags? Well, 2 bags of red would cost $6. 2 bags of yellow would cost $14. This is the very first ratio that we were given. That tells me that, obviously, in Grandma's recipe, it calls for 2 bags of red and 2 bags of yellow. If I keep going here, let's see, 3, 6, 9, 12, 15, 18, 21, 24, and 27. And if I count by 7, 7, 14, 21, 28, 35, 42, 49, 56, and 63. Okay? And if you look carefully, you can see here's that 35. Now I need to figure out, well, what is the number of, or how much money for the red apples? The value of C, that missing value, is 15. The solution to the problem is $15. It's going to cost us $15 to get 5 bags of red apples because we also are using 5 bags of the yellow apples. Now, another way to do this is by using a factor puzzle. Remember, a factor puzzle is like a smaller multiplication table. Well, guess what? It's also like a small ratio table too. It just has less rows. If you look carefully at this ratio table, you can see that it has the red and yellow labels at the top, just like this factor puzzle has red and yellow labels at the top, just like a ratio table does. And it has 6 for the red, 14 for the yellow, 35 is under the yellow as well, and now we're looking for the red. Remember, it's important to use those labels so you know where all of the numbers are supposed to go. Since 6 was for the red apples, I had to make sure it went underneath red, and 14 was for the yellow apples, I had to make sure it went underneath the yellow, and 35 was for the yellow, so again, underneath, and now I'm looking for the red. So all I need to do now is I need to solve this factor puzzle. Let's see, 6 and 14, well, they have 2 in common, and 2 times 7 gives me 14, and 7 times 5 gives me 35, and 2 times 3 gives me 6, so there's my missing number, 15. $15 for the red apples. Now, where in the ratio table are the numbers above and below, so these numbers here, the 3 to 7, the factor puzzle. So if you look at the ratio table from the last slide, remember that 3 to 7, they were at the very top of the ratio table. They showed the basic ratio. So the very top numbers of the factor puzzle are also the top numbers of the ratio table. They're the basic ratio. Where in the ratio table are the numbers to the left and the right of the factor puzzle? So now we're talking about the 2 and 5. Well, the 2 and 5, you actually see them in basically the yellow linking multiplication column, linking unit column. Alright, and then it says write these two numbers with a multiplication sign to the left of the yellow column in the ratio table, and we'll do that in just a second. And where in the ratio table was your answer? Well, the answer was in the 5s row of the red column. So if we take a look back at that ratio table, here we're talking about timesing this by 2, and here we're talking about timesing it by 5. Remember, 3 to 7 was the basic ratio. 2 times 3 was 6, 2 times 7 was 14. There was our very first ratio of red apples to yellow apples. And then timesing it by 5, well, let's see, that gives us the 15, and 5 times 7 is 35, and that was where our answer was. So we were multiplying by 2 here, multiplying by 5 there. Okay. Let's do one more problem together. You're going to see us solving a proportion problem. We're going to use a factor puzzle and a ratio table. Let's see. Noreen saved $20 while Tim saved $35. Take a look at the factor puzzle here. We have N for Noreen, T for Tim. So we made sure that we put labels at the top. So Noreen saved 20. I need to make sure the 20 goes under N for Noreen. While Tim saved 35, so I need to make sure the 35 goes underneath the T for Tim. When Noreen has saved 24, so 24 must go under N for Noreen, how much will Tim have saved? So now I need to solve this factor puzzle. Let's see here. 20 and 35, well, they have a common factor of 5, and 5 times 4 is what gives me 20. 4 times 6 is what gives me 24. 5 times 7 is what gives me 35, which means the missing number is 42. Tim will have $42 saved when Noreen has had $24 saved. Let's see what that looks like in our ratio table. I can see that I have my basic ratio right here of 4 to 7. When Noreen saves $4, Tim saves $7. So I'm guessing this is by day. So on the first day, Noreen has $4, Tim has $7. On the second day, Noreen has $8, Tim has $14. On the third day, Noreen has $12, Tim has $21. You can see the constant increase. Noreen is constantly increasing the amount of money she has saved by $4, and Tim is constantly increasing the money he has saved by $7. So let's keep going here. 12, 16, 20, 24, 28, 32, 36, and for Tim we have 28, 35, 42, 49, 56, and 63. Okay, and let's see. Oh, what are we multiplying by? Well, obviously 4 times 5 is what's giving us the 20. And 7 times 5 is what's giving us the 35. And here I'm multiplying by 6. 4 times 6 gives me 24. 7 times 6 gives me 42. So you can see the 5 and the 6 are the numbers that we're multiplying by, right? 5 times 4 is 20. 5 times 7 is 35. 6 times 4 is 24. 7 times 6 is 42. So the ratio table, just like the factor puzzle, has the numbers we're multiplying with on the left and the right side, and the ratio table and the factor puzzle have the basic ratios on the top. Okay, takeaways. A proportion. Remember, a proportion is when you have two equal ratios. When you're solving a proportion, that means you're finding the missing value in a set of equivalent ratios. Usually you're given 3 numbers and you have to figure out the missing one. And you can solve a proportion by making a ratio table or by using a factor puzzle.